Okay. All right. All right. Let's see. I'm going to bring up Nick. Okay. All right.
Hey.
Hey. Nick Canzoneri?
Yeah.
Whenever you have to say these out loud for the first time, it's who knows. Okay, so Nick is going to talk about kind of transactional email. Pretty much all of us at this point are sending emails from our apps, but Laravel makes it so ridiculously easy that sometimes it hides the actual complexity under there, or just best practices and things like that as well that you might need to do on your end of the app. So Nick's going to take us through all that. So how about it, Nick?
All right, great. All right, so like Ian said, I'll be talking about what developers can know about email. Just want to say thanks to Ian. It's been a great conference so far. All the other speakers have been great, so hopefully I can keep the streak going. A little bit about myself. I grew up on a dairy farm in rural Pennsylvania, and I'll give myself a little test to prove it to you guys. So this is a black and white Holstein. This is a Jersey. This is a Dutch belted. We had a few of those. They're a little rare. But the end result of growing up on a farm was that I knew 100% I did not want to be a farmer. The job is way too hard, so I tried to find the exact opposite, which was technology. So that's how I kind of got into programming and things like that. Right now I work at Postmark, and I have for about like 3.5 years. What do? We send out email. We're transactional only, so that means not newsletters, not spam, but password resets and welcome emails. You know, the email that you actually want to get, need to get. Working for an infrastructure company like this is really a unique experience to get really deep into a niche industry like email. It's a really complex topic, and you know, as like just a developer coming out of school, you have kind of a lot of vague assumptions about how email works, especially today. It has changed a lot, actually, and just, you know, underestimated how much there is to it. One of my favorite stories is from one of our customers, Mojang, the company behind Minecraft. Now, you might not think that Minecraft has a big email component to it. The game doesn't. But they email out your license code when you purchase. And that email is really important to their business. Before Postmark, they had set up a dedicated server to send these emails, but they hadn't really done any of the detail work to make sure that emails were getting delivered. You know, they were focused on making the game. Customers started complaining about missing email keys, and Mojang's support queue kept filling up with unhappy customers. So they were looking to hire a ton of customer support staff to handle these missing keys until they moved to Postmark. And so they were able to set up Postmark and start sending emails reliably and quickly. And now they don't have to worry about those email license keys missing from the inbox. So like Ian said, pretty much everyone needs email. My talk is a little more generic, focused on email concepts that you can use anywhere, because every web app needs to send at least a few email. And if you're sending only a few email, then that means that they're that much more important. So I gathered up a few different topics about things that are overlooked or misunderstood and will help you send better email. What are MX records? How is an email formatted? Why do I need email authentication? And how do I get more features out of email? So we're going to start at the first thing that needs to happen when you need to send an email to someone. So I want to send an email to alice@example.com. How does that work? Well, the sender is going to split up the different parts of the email. So the first part, Alice, is called the local part or the mailbox, and example.com is the domain. From the domain, the sender needs to figure out, you know, what the address is. So going from domain names to addresses, we use DNS. Everything with email uses a lot of DNS, as you'll see further on in the talk. But for sending an email, we need to look up a specific DNS record type, which is MX, or mail exchanger record. And there can be multiple MX records for a domain. Some confusion that we see is about subdomains. So a subdomain doesn't inherit anything from the main domain. It's treated as like totally unique and separate. So if you want to get email to receive email on a subdomain, it needs its own MX records. So going back to multiple records, as you can see, they're differentiated by a number at the beginning. This is called the priority, or preference, or distance. Distance might be the easiest way to think about it because the lowest number is the one that is most preferred. So you want to travel the shortest distance. So for here, that's how the different MX records would get chosen. You know, DNS doesn't have any inherent ordering built into it, so they had to add the priority number. So let's take a look at a real world example. If you have Google Apps, these are the records that Google tells you to add for your domain. This is going to be the first MX record that's tried. If it succeeds, then we're done. None of the other MX records are needed. But if that first server is down for whatever reason, you go up in the priority. So these two servers are at the same priority level, and the sender is supposed to choose randomly which one to send it to. So ideally, the traffic should be split evenly between those at the same priority level. And if those servers are down as well, then you move again up to the priority level and choose randomly between the ones at the 10th priority place. One thing to know is that the exact decisions on when to move to the next priority are a little bit iffy and depends on the implementation. Generally, if the server is totally down and unresponsive, then a mail sender is going to move up the priority. But if the server is slow or returns an error in response, then it gets a little fuzzy, so it might retry the first priority a few more times. So it's a little bit iffy. And so everyone works a little differently. So that's the high-level overview of MX records. So it's a special type of DNS record, MX, not text. Subdomains need their own records, and the lowest priority is the most preferred. So next, we're going to go over how an email is formatted, how it's actually built up. We're not going to go too deep, but there are some things that are useful to know. Hopefully, you have a great library like Laravel to build up all these parts for you. But there may come a time when you need to dig into the email format yourself. And so there are some things that are useful. So let's take a look at RFC 5322, Appendix A 61. Now, emails do involve a lot of RFCs, but I'm not going to torture you with that. We're going to go over three things. So the headers, the body, the attachments, and how they all fit together. So first off, headers are metadata, information about the message, not the message itself. Some of these headers get exposed in our email clients, so it's information that we're used to seeing. From, to, subject, date, they're all headers. So they all use this name : syntax to get built up. But there's a lot more information that can be found in the headers if you need it. This is an example of an email that I got from Amazon. A lot of it is very verbose, but there can be some important pieces of information you can pluck out. One piece of information that's probably important to all of you as developers are the received headers. A common complaint from one of your customers might be, hey, it took 15 minutes for me to get your email. What's wrong with you? And just with the complaint, there's nothing you can really respond with. But if you have the received headers, you can prove some things. So how received headers work is that as an email gets relayed from SMTP server to SMTP server through the internet, each server adds a received header with some information. So here's kind of a basic received header and the three main pieces of information in each one. So where did it come from? Who has it now? And when that transfer took place. So with these pieces of information, you can track the email's entire path through the internet. So the headers build on one another like a stack, and the most recent is at the top. Here at the bottom, you can see, Basecamp handed the email to Google at 6 o'clock. And then it took 1 minute for Google to relay it internally. The good news is that you don't need to remember how to parse these received headers exactly, because Google has a pretty neat tool to show you exactly the whole path. You paste in the message headers, and they display the received headers in a really nice format that shows the delays along each step in the process. So for this example, you can see this is an example straight from Google's site, and you can see conveniently that 19-minute delay took place before the email ever even got to Google. So it wasn't Google's fault. But I think this tool really displays the information in a nice, easy to read format. Last bit on headers are X headers. So X headers are headers that start with an X and a dash. This is the accepted way to do custom SMTP headers for whatever information that you want to add. It's pretty common for spam filtering systems to add spam scores as X headers. And it's very useful for you to add your own diagnostic information from your own application, like a user ID. So why is this useful? One reason is that if a customer comes in support, you can have them forward you the email or paste the headers, and you can know exactly what email that they're talking about. And the second more important reason, and we'll get into a little bit more later, is that all your custom headers are included in email bounces. So this can make hooking up an email bounce to your original email really easy to do. So the body of the email. You have all your headers followed by a new line, and everything after the new line is considered the body of the message. The body can be HTML, text, or something else, but email clients need a little bit more in order to know how to display it properly. Here we're able to use the power of a content type header to show that the message is plain text. And if the email body is HTML content, the content type header will show text HTML, and the email client will know, don't display this text, display it as HTML. So as you probably know, you can also have multiple different content types. The way that SMTP uses to format the email is by using boundaries. That way you can have multiple parts of a body that is treated differently. So the first content type header defines the boundary. In this case, we're defining alternative parts. So the email client can choose to display the text or the HTML part, but you wouldn't want to see both at the same time. There are alternative parts. So here are all the boundaries, and you can see the individual parts in between the boundaries. So there's our individual text email, and there's our individual HTML email. It's pretty rare, but there are also other types of content that you can have in your email as well. For example, if you have a content type of watch HTML, only that content type will get displayed on the Apple Watch instead of the existing text or HTML content. It's a little bit weird because, Apple decided to do this. It is not like an open standard or anything. This is a very special Apple Watch specific thing, but they added it, and it's useful if you have that sort of customer base, because you wouldn't want to make the same HTML email to display on a desktop and the Apple Watch at the same time. So you can add this alternative part to the email. So going back to HTML bodies for a minute, most browsers and clients will render a plain H1 tag. But really, your HTML emails should be a full HTML document. So to make sure it renders in the most amount of places, it should have a doc type, the HTML and body tags, just like a web page. Email clients are, email clients are not HTML5 ready. So you need to go back to the old XHTML doc type, unfortunately. As a side, HTML emails are pretty complicated. I'm not going to talk much more about this because it's way out of my expertise, but we've published at Postmark a bunch of HTML email templates under an MIT license that you're free to use, and it's really awesome that Laravel is using these templates. So that's exactly why we built them. It's really great. So you don't have to worry about writing HTML that's compatible with emails. So this short amount of code makes an HTML email, and this is what it looks like. All the CSS has been tested in a bunch of different places and email clients. And if you have any issues, you can open up a GitHub issue with us. All right, back to email formats. So now we get to attachments. So remember that our email format is split up into different sections via the boundaries. This is going to get a little bit complicated, so I'm going to show it in a different way. Cutting out the boundaries that we talked about and just presenting the formats in a hierarchical way. This is what we have now. In a multi-part alternative, there's text, HTML, maybe watch HTML, and attachments bring another level of nesting into the picture. Now the entire body is wrapped in a multi-part mixed content type, and the attachment bits get appended to the bottom. Remember that it's all still split up using the boundary tokens, and to get this level of nesting, I'm not able to show it on a slide and have it be readable, but this is the way that the email is structured with attachments. So this is kind of like a logical view at it. The last bit that you need to know about attachments is base64 encoding. So it's a binary to ASCII encoding format, and that's how you're able to get a binary file like a PDF embedded into an email. The problem here is that with base64 encoding, the size can increase by up to 30%. So that's a pretty big size increase. And this is the reason why you have all these issues where, Hotmail says I can get emails up to 25 megabytes in size, but that doesn't mean that the file, the email, the PDF that you attach to your email can be exactly 25 megabytes, So if you're building an application that sends attachments and things like that, you might want to, pull back your limits a little bit to account for this big size increase. So recap on how an email is formatted. Headers are metadata. You can add your own with X headers. You want to have fully valid HTML documents for your emails. And base64 encoding can increase attachments by up to 30%. So the next section I'll go over is, why do I need email authentication? So email was built in a time where, like most of the internet, everyone knew and trusted each other. You want to send me an email? Great, I'll take it. I trust you completely. But nowadays, you can't trust everyone, and bad actors are going to find ways to exploit systems. I love this sign. So if you can't read it, it says, beware zombies ahead. And so people are going to find a way to mess with you. There are three main methods of email authentication that are used. They all solve slightly different problems, but they all come together to form a good defense. And so that's SPF, DKIM, and DMARC. And you'll want to use them for two main reasons. If your app or domain is a target, like PayPal, and, where people are actively trying to pretend that they're PayPal, these methods will provide spoofing protection, so that people won't be able to send emails that look like they're from your domain. But for most people, you're not targets, hopefully. And the main reason why you want to use these methods are deliverability. It is more likely that your customers will get your email if you pass these authentication methods. And it's for the simple reason that your emails will look more legitimate to receivers of email like Gmail and Hotmail if you pass these methods. It's like walking into a restaurant without a shirt. You might be a perfectly nice person, but there's a certain basic level that you should keep up. So the first thing that we'll go over is SPF. It's the oldest authentication method. It stands for Sender Policy Framework. It's got a website, an RFC. It's an open standard. SPF is all about defining what servers are allowed to send email for your domain. So what's allowed and what's not allowed. A whitelist and a blacklist. It's pretty simple. The first thing that you need to keep in mind is SPF is domain-based, and it's the receiver of the email that does the checking. The receiver looks at the return path header which is who actually sent the email. So in this case, it's bounces@example.com. And from there, the receiver is going to look up a text record for the domain. And if it starts with v equals SPF1, then that's the SPF record. So this one is saying, though it's saying plus IP41111, that means that that IP address is allowed to send emails for that domain. The next one is minus 2222, and that IP address is not allowed to send emails for that domain. And so for everything else, it's an all syntax. And that means do a soft fail. I'll go over that quickly. So the full SPF syntax is pretty complex, but let's look at a real example, GitHub's. I cut a few things out, but this is most of it. So this is an IP4 mechanism, and this defines an IPv4 address range. So for in GitHub's case, this must be their servers that are allowed to send out email. The next bits are the include statements, and this is what you'll have to interact with most of the time. So what this does is says that the SPF record at this domain should be substituted right there. Basically, you're authorizing Google and Zendesk to send emails on behalf of your domain. The reason why it's done this way is that Google and Zendesk can add IPs, they can remove IPs, they can manage everything on their end, and you don't have to update anything. So last is the all mechanism. It basically means everything else. Excuse me. SPF records are checked left to right, so anything that matched would have stopped already. So the tilde means a soft fail. It means that email receivers should log that it failed, but still deliver the email. So this is kind of the safe thing that you should do. So if you're not sure where all your email is coming from and you're making an SPF record, use a tilde for a soft fail. So that way, legitimate emails can still get delivered. If you're sure that your SPF record is correct, you can change that to a minus sign. And that means that emails that don't pass SPF should get rejected. They're not going to get delivered at all. Like I said, you should make sure that you know all your email sources before doing that. So there are a few gotchas with SPF, like anything. You can only have one SPF record. This is very important. So every time you add a new service, you have to modify your existing record. If you have multiple SPF records, everything is invalid. So in this case, if your company wants to add Zendesk, you have to modify the existing record. If you had two records, that would be invalid. So you have to combine them all into one record type. The next one is that there can only be 10 lookups during an SPF check. This means that your record has to have less than 10 of those include statements, or your SPF record will be invalid too. If you have the type of team that likes to add or try out a new service every week, and your SPF record keeps getting longer and longer and longer, your SPF record might be in trouble, and it might be invalid by default. So next up is DKIM. It's another open standard with an RFC, but its purpose is a little bit different. So what problem is DKIM trying to solve? So remember the way that SMTP routes emails across the internet. It can be relayed across some servers that are out of your control and out of your recipient's control. So how do you prove that any of these servers in the middle aren't modifying your email? How do you prove that the message you got is exactly what the sender sent? The answer is DKIM. DKIM uses public-private key encryption to add a cryptographic signature to the message. So there's three main pieces: the private key, the public key, and the signature. So DKIM private key is stored secretly by the sender. If you use a service like Postmark or SES or Mailgun, that means that emails that you send through them will get a signature based off of this private key. And this is an example private key that I newly generated. I didn't copy it from our servers. The public key is located in DNS. So remember, email has everything, a lot to do with DNS. And the idea is that if you have control of DNS, then you can trust the public key is accurate. To use Google Apps and GitHub again, as an example, so this is the DNS record that Google Apps tells you where to store the public key. And so it's kind of split into 3 different parts. So this is the selector, and this part will be different for every service you have, and it's just an identifier. This is the special subdomain that is DKIM specific. So underscore domain key, and the idea with the underscore is that hopefully it won't conflict with any legitimate DNS records that you want to add for your domain. So the underscore domain key is kind of like a reserved piece for DKIM itself. And the last bit would be the signing domain. So in this case, github.com. And this is what the text record there looks like. It looks, the value is, kind of your typical public key just in DNS. And what this all results in is an SMTP header that gets added to your emails with the name of DKIM Signature. And so receivers of the email can check this to verify that the message wasn't changed. It's created by using the private key plus the content of the message, and it's checked using the content of the message and the public key. So you can see in here a little bit the H equals. So what DKIM also protects against is not only the content of the body, but also some of the more important headers to make sure that those weren't modified as well. Not going to go deeper into that because I'm not a security expert and I don't know much more about public-private key encryption than that. But if you have any more questions, you feel free to ping me. But that's about what I got for DKIM. So the last method is DMARC, and this is the newest one. It really only became finalized in 2012, and it's really only been in heavy implementation recently. So like everything else, it's an open standard with an RFC and a website. So what problem is DMARC trying to solve? So with SPF and DKIM, you, the sender of the emails, get to define the parameters of what passes or fails. You don't get to decide what happens when a pass or failure occurs. Well, a pass hopefully is obvious, it goes to the inbox. But it's up to Gmail and Microsoft what to do with the email if they fail SPF. Gmail generally puts the emails in a spam folder. Yahoo generally kind of rejects emails. But DMARC lets you decide what can happen. Your DMARC policy is based on your domain, and it's again located in DNS using the special underscore DMARC subdomain. This is Gmail's DMARC policy. The cool things about having them all in DNS is that they're public, and so you can look at what other companies are doing. And your DMARC policy has 2 main parts. So this is the policy. It can be none, reject, or quarantine. And that says what to do with emails that fail SPF or DKIM. So with none, it basically means still go on and deliver the email. Quarantine says to put it in a spam folder. And reject says to don't even deliver the email, reject it outright. None is definitely the safest option until you're absolutely sure you're not rejecting valid emails. And the second part to the DMARC policy is an email address where reports go. So this is kind of a cool piece of DMARC is that receivers of lots of email, Yahoo, Gmail, Microsoft, they check DMARC and they're going to send you a report for your domain. It's telling you all the IPs that are sending email for your domain and whether they pass or fail. One caveat about those reports is that they're gzip XML files, so they're a little bit hard to read. So we built a free tool at dmarc.postmarkapp.com that aggregates all your reports and sends you a nice weekly email about what IPs pass and fail. If you're interested, sign up and we'll show you what kind of DMARC record to create, and it will help you understand what IPs are sending email for your domain. And then you can make the decision on how to fix those emails. Checking validity for these different authentication methods. You can send an email to Gmail and they'll check for you. So once you get an email into Gmail, you can click a little drop down and go to Show Original, and it'll pop up an extra page with a bunch of information. So here's a recent email I got from GitHub, and Google cleanly shows that GitHub's emails pass SPF, DKIM, and DMARC. So, it's kind of still the method that I use to check, if I'm setting up a new domain, if I've got everything set up right. So to recap on why do I need email authentication, SPF is a domain-based way to say what IPs are allowed or not allowed to send for you. DKIM is a message-based way to verify that the email isn't modified. And DMARC tells receivers of email how to handle authentication failures for your domain. So the last section, how do I get more features out of email? And I think there's 3 main pieces that you can hook your app up with that can really provide a big bang for your buck. So they're not major features, but if you can incorporate them, they can make for a nice wow factor. So they're bounces, opens, and inbounds or replies. These types of features do rely on some more complex pieces of architecture that comes from sending your own email. I wouldn't recommend building these from scratch. You don't want to run SMTP servers or spend a lot of time parsing emails. Postmark and other email providers like SES, SendGrid, Mailgun, SparkPost, they provide these features, and they're infrastructure companies for the reason that they're reliable. And if you're using these companies already, these features are probably already available to you. You just have to use them. So you can use API or webhooks that these companies provide to get all this information to your app without only writing a small amount of code, hopefully. And hopefully you don't have to deal with the technicalities of email, but you still get the benefits of these features. So first up is bounces. So what does an email bounce mean? It means that the email that you tried to send didn't get delivered. It could be for a huge number of reasons. Maybe someone mistyped an email. Maybe their inbox is full. Maybe your from address is getting blocked. The end result is that the recipient did not get your email. Bounces are an important stat for you to keep track of, to know your overall deliverability rates and to make sure that people are getting your email. But there are certain cases where you can go the extra mile and expose this data in some cool ways. So I'll show you an example of how we use bounce tracking within our own app at Postmark. Our web app is a full-fledged user of Postmark. It has its own account and everything. We don't have any secret entrances. One of the first features that we dogfooded was bounce handling. So you can add a user to your Postmark account, it sends the invite link via email, and the user has to click on it. Pretty much the standard add a user flow. But it can be really annoying if you're like me and I cannot type and I mistype that invite email address. So you can keep resending the invitation, but that's not going to work. And hopefully when you delete and re-add the user, you get the email address right. But we built showing bounces right into our web app. So here I added a non-existent user, and it shows bright in red that the user did not get that email. And if you click into that, we show the exact reason. So this email account didn't exist. And hopefully then I realized that no one here is the wrong email address. As far as implementation goes, you do have to store some more data. So this is an example table structure about user invites. It can obviously be whatever. This is just a quick example. But you can add some more data to here. So when you get information about a bounce, like via webhook, how do you populate that information back to the invite? So remember, you can use X headers. So when you send out the invite, you can add an X header of the user ID or the email, or maybe the ID of the invites table. And so that way when the bounce comes in, you can just look up your own special X header, and linking the two together is very easy then. So the next bit is dealing with email opens. So this is tracking if a user has opened or viewed an email. This can be a little creepy if you go overboard, actually. I've heard stories of people, setting up a sales call saying, I see you opened my email 10 minutes ago. Don't do that. There are subtle ways of using this and that provide a benefit to you and your users. So the biggest reason to use open tracking is for the stats. So you can sort of think of it like Google Analytics for your email. So it's really the only way to get sort of like browser info, email client info about how your users are viewing your emails, and it can help influence some important decisions for you. In particular, how you design your emails, whether for mobile or the desktop. So if the majority of your users are opening up email on their phone, that might help you decide how to create the email in the first place. When it comes to features, examples are a little bit harder to find, but I came across a great example from Help Scout. So it's a support platform, that handles tickets and customer outreach and such. They aren't a Postmark customer, but we use them at Wildbit. So I'm not sure how many of you all do support, but sometimes there's a bit of anxiety around, did they see the email, did they not? Especially if it's something important like billing. You always wonder, oh, should I send another one? It's been 10 minutes. Help Scout has this little feature letting you know when the customer has viewed the email. And it's nice because it takes the stress out of the situation, and you know that at least you've done your part in sending the email, and it's up to them to respond now. Lastly, let's talk about inbound processing. So this basically turns an email into JSON that your application can consume. So your customer can send an email to your application. This can be one of the most powerful ways to add email interactivity to your app, but it's also one of the most complex. And I think it really only makes a big difference in certain application. If your customer base are really heavy email users like salespeople, if they can reply to an email and have it do things in your app, that's pretty magical. Kind of the classic example is Basecamp or Jira or some other project management tool where you can reply above this line to have the comment added to the topic on the website. So here we have an email that a customer sends to you. And if you want to take action on it to parse out the necessary pieces of information, that would be a lot of work on your part. Luckily, Inbound turns the email data into JSON, which is obviously very easy for your code to work with. And so like all the major email providers support some form of inbound. So it's nice that, yeah, you kind of don't have to worry about parsing the email yourself. Again, specific inbound examples are a little bit hard to find, but here's another example from Help Scout that they let you do special actions in an email reply via special syntax. For your application, it's really up to you what you want to allow users to do. But hopefully, like with inbound, it's limited by what you want to do and not limited by dealing with email. As far as setup goes for inbound processing, the thing that you need to keep in mind is that you need to set the reply to address to have all the information that you need to link it up with the original message. Because this is an email reply and not a bounce, you're not going to get those X headers that you can add. So as you can see here, the reply to address has a bunch of information in it that, and so that's what you need to set up in order to link it to the proper place. Another example of inbound is the DMARC app that I was talking about. So like I said, DMARC specifications give you reports by emailing you a zip file. And so we used our own inbound processing when building this tool. So it made building this little tool a lot easier to do. And because we just got the email attachments by JSON. And so we're able to build out the tool pretty quickly. So to recap, bounces, you need to know why you can't contact your customer. And if you let them know that, that's an extra benefit on your part. For opens, little pieces of information can have a high impact. And for inbound, closing the email loop can provide, a really high level of email interactivity. So I think I went pretty quickly. That's all I have so far. Set up a little special laracon.postmarkapp.com. And if you make a purchase by June, we'll double it for you. So that is me.
All right, thanks a lot. Tons of complicated and interesting things in email. Someone who deals with a lot of email myself. do have a couple questions. Some of these might be tricky, so feel free to punt. One came up. I don't know if you guys even deal with this, GPG signatures and emails and things like that.
Yeah. So GPG gets a little complicated. We don't deal with that with Postmark because of the fact that when you relay an email through us, it's not a straight relay. We kind of like break it up and build it up again. So any GPG signatures that you have beforehand, don't work anymore, unfortunately.
Okay. Let's see. This one's also a little tricky. Every question with email is always a little bit tricky.
Right. Yeah.
Universal. Okay. This is basically, I've hit this, I think, myself. When you're sending emails on behalf of your customers, and the only thing you can really do is send the reply to header, but like older Outlooks and some other things don't really like the reply to header or display it correctly and things like that. So is there tips or tricks there?
Right. Yeah. So yeah, like you said, the main if you're not allowed to touch your customers' DNS records, then pretty much your only option is to set a reply to, unfortunately. But because of the increase in, so one of the things we say is that for your application, you do want to send emails from your own domain. So I know customers don't like to see that, but it does become useful. So there's a couple of reasons why. So one is that you kind of like email reputation is getting more and more domain based. So if they see your domain sending good email, like Gmail will recognize that and let your emails become, make sure that your emails are delivered well. Whereas if you're sending on behalf of your customer, then it depends on your customer's domain reputation type thing. Right. So there is a benefit to sending emails under your own domain.
And I think reply to is pretty well supported in most modern mail clients, right? It's just kind of something.
Right. Yeah. It depends on the situation where, if you wanted to go directly back to the person, then, you need to use reply to. If you're building sort of like a base camp or something along those lines, then you can use inbound processing maybe to feed the email back into your own application anyways.
So let the email come back to you and then you do process it and you might just even forward it back on to the customer or something else.
Right, yeah. So it depends on what you're building.
Both directions.
But in general, the reply to is kind of your only tool there.
Yeah. One other thing that I didn't know if this has changed, maybe I might have just slightly missed it because I'm multitasking here, but with the open tracking, that's still not super reliable, or is that not true? I know you could use an image to see if they opened it or if they click a link.
Right, yeah. So the common tactic is using an image, and you're right, it's not reliable 100% of the time. So if you send only text emails, then you can't put an image in a text.
Right.
And also with Google, basically they do image caching and proxying, so you can still get you can still know if the email was opened, but you don't know what browser or what client. You just see that the image was opened from Google.
Right. I gotcha.
It's fairly reliable. So especially with the changes that Gmail has made recently. So beforehand you had to click something to show images, but now if your emails pass authentication methods, most of the time, emails will display, Gmail will display images automatically. So you get that back again.
Right. And I think HTML email is more accepted and common now than it was 5 or 10 years ago, where
definitely
people, Outlook defaulted to text even and put things like that, where a lot of them default to HTML.
Yeah. As an aside, I think the majority of the emails that Postmark sends out is to Gmail. And so Gmail handles it pretty well, actually. And so Gmail is pretty popular. So.
Yeah, that's interesting. I don't know if you have those stats right handy, but what are the top 3, that you guys send to?
Gmail is like the big gorilla in the room. Yeah, I don't remember the other ones offhand.
Yeah, Gmail's the monster now, right?
Yeah.
Interesting. All right. Well, thanks a lot. There's some other questions and other antics going on in there, so you can take a look in Slack and
Great.
those. But thanks a lot for the talk. Great stuff. I think some a topic that not everybody knows that much about, other than just sending it. And I mean, I've been doing email for 15 years or whatever now, and some of those tools in there are new to me and stuff. So it's really good stuff.
Yeah. No, it's been around forever, but it's actually still changing, and new things are getting added. So.
Exactly. All right. Thanks a lot.
Thank you.